Welcome. My name is Martin Litwack, a lecturer in the Mathematics and Computer Science Department at Kingsborough Community College. This video provides worked out solutions for Sample A of the CUNY Elementary Algebra Final Exam. Sample A can be found at the link in front of you. Your feedback is encouraged. You can email me at mlitwack@kingsborough.edu with comments and/or suggestions. Now, please keep in mind that most problems in math can be solved in more than one way. The methods I've chosen here may, therefore, differ somewhat from those used by your instructor. This is normal and to be expected. So if you already fully understand how to solve a particular problem type, you should probably stick with it. On the other hand, if you are having difficulty with a particular problem type, this video will hopefully help you understand it better. I have solved most of the problems in only one way in order to avoid confusion. However, occasionally I have provided more than one solution in order to more fully explain an underlying concept. Well, good luck and let's begin. Again, I encourage you to download this sample exam if you haven't already from the following link. Okay, so problem number 1 is 7 squared to 24 minus 3 squared to 6. Now remember, in math there's a principle that you can only subtract like terms. So here it's as if you have 7x minus 3y. Now you know you cannot subtract that. And in the same way, we cannot subtract the square root of 24 and the square root of 6 because they are unlike. The radicands are not the same, 24 and 6. Well, we always have to simplify square roots, so let's see what happens when we simplify it. Perhaps when we finish simplifying, we will be able to subtract the two square roots. Now, when we simplify a square root, we're looking for the square root to go all the way all together. So if we look at the square root of 24, we see there's no square root of 24. There's no number that when multiplied by itself twice would give 24. So the next best thing we can do is make the radicand as small as possible. And we do that by looking for the largest square factor, if any, in 24. So we see that the largest square factor of 24 is 4. So we'll rewrite 24 as 4 times 6 and just repeat these 3 times the square root of 6. Now at this point, there's a rule, the multiplication rule for square roots, that permits us to rewrite the factors under the square root sign as separate square roots. It's as if they're getting a divorce. And we'll do that right now. Little heart, as if they're getting a divorce. And we'll rewrite it as 7 square roots of 4 times the square root of 6. So each factor in the radicand gets its own home. The square root of 4 times the square root of 6. And we're still subtracting the square root of 6. Now we see that the square root of 4, since the 4 is a square, the square root of 4 is 2. So one of these square roots goes away. So we have 7 times 2 times the square root of 6 minus 3 square roots of 6. And we see now that the radicands are going to wind up being the same, because 7 times 2 is 14, and we have 14 square roots of 6 minus 3 square roots of 6, and the final answer is 11 times the square root of 6. Problem number 2. Now when we see something of the form a outside the parentheses times a binomial inside the parentheses, we know we need to use the distributive property. So we're going to multiply the square root of 15 times the square root of 5 times the square root of 15, followed by the square root of 5 times the square root of 5. Now, when we multiply the square root of 5 times the square root of 15, what we're going to do is use the multiplication property for square roots again, and we're going to marry the two square roots. They're living separately now, so to speak. So what we're going to do is put them under one roof. So we will wind up with the square root of 5 times 15, all under one roof. And we'll repeat that for the second multiplication, the square root of 5 times 5. If we multiply out now, we get the square root of 75 plus the square root of 25. Now you always have to simplify when you have square roots. Remember, simplifying is going to involve one of two things. Ideally, we'd like to remove the square root sign altogether. And you see, you can do that actually with the square root of 25, because that's simply 5. But there is no square root of 75. So the best next thing is to reduce the size to make the 75 as small as possible. That's considered simplification as well. So the way we do this is we look for the largest square factor of 75. And we know that is 25. So we'll rewrite 75 as 25 times 3. And we can now write 5 for the square root of 25. All right, so whereas before we married the square roots when they were living separately, now we're going to divorce them when we go through the simplification process. And we'll have the square root of 25 in one square root times the square root of 3 in its own square root plus the 5 from before. The square root of 25 equals 5. So the final answer is 5 square roots of 3 plus 5. In problem number 3, you need to multiply two numbers, both of which are in scientific notation, and place the result in proper scientific notation form. Now, a number is in proper scientific notation form when it's of the form a some number times 10 to the n, where a has to be between 1 and 10. 1 is included, but 10 is not. Now the way we do the multiplication is to multiply the 3 times the 4, the decimal numbers together, which gives us 12. And then we multiply the powers of 10 together. We do that by adding the exponents. So 6 plus negative 2 is 6 positives and 2 negatives, so we're left with 4 positives. Now you notice our answer, 12 times 10 to the 4th, is actually one of the choices, choice A over here. But it's not the correct choice. Do you see why? Well, the answer is because the 12 needs to be between 1 and 10, and it's not. So we need to figure out a way to do that without changing the value. We want to change the form of what we have, but not its value. So the problem is the 12. All right, so let's see how we could make that between 1 and 10. Well, what we can do is we can move the decimal point in the 12 to be between the 1 and the 2. That would give us 1.2. That's good. That's between 1 and 10. But we changed what we started with. We need to keep the same value, the 12. So 1.2 is too small. So our exponent is going to have to be positive to make the 1.2 larger. And we move the decimal one place, so we have a power of 1. Now we still have the multiplication times the 10 to the 4th. So our final answer will be 1.2 times whatever 10 to the 1 is times 10 to the 4th. We add the exponents again, so we see our final answer is 1.2 times 10 to the 5th. Problem number 4 asks you to simplify. So you're being tested on your knowledge of exponents. Now we'll do that the way you usually do it, the way you've been taught to do it, but I'd just like to show you something where you can see that we can really make this kind of problem really easy, and you don't need a whole bunch of rules. So I've rewritten the problem here. All you have to know is what an exponent is. Now, an exponent is nothing other than how many times you multiply a number by itself. So if you look at the numerator here, you'll see that you have x times itself 5 times, multiplied by x times itself 7 times. In the denominator, you have x to the third power. That's x times itself 3 times itself twice. So that gives us x times x times x times itself again, x times x times x. Well, at this point, all you have to do is cross out. So let's have some fun. Go away. Cross out, cross out. You've known how to cross out for some time. Cross out, cross out, cross out. One more. And you see now, and you literally can see, that the final answer is x times itself 1, 2, 3, 4, 5, 6, 6 times. And you notice we didn't make use of any rules. We didn't have to memorize any rules. An exponent is just a shortcut. So if you remove the shortcut and write what it is, some number times itself, that number of times, then you just can cross out and you're done. Okay, so now let's go back to the problem and do it the way you usually do it. Now, students very often come to me and say, well, what do? Do I add these exponents? Do I multiply the exponents? When I get a question like that, it really means they don't understand what's going on. They're just trying to memorize, and not a very good strategy. If we look over here, we see we have x times itself 5 times and x times itself 7 times. So in all, we have x times itself 12 times. So we understand, oh yeah, I do have to add the exponents in this case to get x to the 12. Now in the denominator, students are usually taught, when it looks like this, you just multiply. Well, why? Because you have x to the third times x to the third twice, so there's going to be two sets of 3's where the x is multiplied by itself 3 times. So the final answer in the denominator, or the answer in the denominator, will be x to the 6th. And now you're taught to subtract the exponents. Why? Well, if you have 12 of them on the top and 6 on the bottom, 6 are going to cross out like we saw, and you're going to be left with 6 on the top. So the final answer is x to the 6th. Problem number 5 asks you to subtract two polynomials. The first polynomial minus the second polynomial. Now, there's actually a number missing here, because when you're asked to subtract the second polynomial, there is really an invisible 1 here. Because if you were being asked to subtract more than one of them, there would be a 2 or a 3 or whatever number. And since there's no number there, it's really 1. So we can distribute to find the values in the second polynomial. So let's do that right now. We'll repeat the first polynomial. So we have 5x squared minus 7x plus 9. And now let's distribute. Negative 1 times negative 2 will be positive 2x squared. Now you could write these numbers, these terms that I'm writing now, starting with 2x squared, to the right in this area over here, but it makes it easier if you line up your like terms, if you write the terms of the second polynomial vertically. Continuing to distribute, we get negative 1 times negative 3x, which is positive 3x, and negative 1 times positive 2, which is negative 2. Combining like terms, we get 7x squared minus 4x. And the reason for negative 4x is because the negatives went out by 4 plus 7. So the final answer is 7x squared minus 4x plus 7. In problem number 6, you're asked to multiply two polynomials. Now, since neither polynomial has any like terms within it, you'll have to multiply in pieces. This is called distributing. So we're going to distribute or multiply the 2x times each term in the second polynomial. We'll start by multiplying 2x times x squared. We'll get 2x to the third power. Then 2x times positive 4x. And finally, 2x times negative 6 to give us negative 12x. Now we'll distribute the negative 5 times each term in the second polynomial. Now you could put those answers immediately to the right of negative 12x and then see which terms need to be combined, which terms are like. But I find it easier to write the remaining terms in a vertical way to make it easier to see which terms are like and to combine them. So negative 5 times x squared is negative 5x squared, and I'll put that in the x squared column. Negative 5 times 4x is negative 20x. And finally, negative 5 times negative 6 is positive 30. It will have to go into its own column since we have not had a product that is a pure number. So we get 2x cubed. 8x squared minus 5x squared is plus 3x squared. Now don't fall into the trap of doing anything with the exponents, because the exponents have to stay the same here. If someone gives you 8x squared and he takes away 5x squared, it's 5 of them, then you have 3 of them left, 3x squared. Now minus 12x minus 20x, you have negative 32x's in all, and then plus 30. And that's the final answer. 2x cubed plus 3x squared minus 32x plus 30. Problem 7 asks you to simplify this somewhat intimidating large fraction. Now there are two ways to do this. The first way is to break this fraction into smaller fractions. But before I do so, let me show you why this works. So let's look at the example. 1 over 7 plus 2 over 7 equals 1 plus 2 over 7, since when the denominators are the same, we're permitted to add the numerators. We could swap the left and right sides, and we would get 1 plus 2 over 7 equals 1 over 7 plus 2 over 7. So in general, for each term, something being added or subtracted, in a numerator, it gets its own smaller fraction with the denominator in the original fraction. Now let's return to the original problem. Here we have 3 terms in the numerator, so we can make 3 small fractions, and each fraction will have a term from the big fraction, its numerator, and our denominator of negative 5x. So first fraction will be 25x cubed over our denominator, negative 5x. The next fraction will be minus 35x squared over negative 5x. And finally, plus 5x over negative 5x. Now at this point, each fraction will have a sign when we're done simplifying it, as well as what the simplified result is. So let's take care of the sign first, and then we don't have to care about the sign any further. So of course the sign of the first fraction will be negative. The sign of the second number will be positive. And the sign of the third fraction will be what? That's right, negative. And now all we do is cross out. 25 over 5 is 5. X to the third over x. We have one x cross out, so we're left with 2x to the second power. 35 over 5 is 7, and x squared over x is x. And here you have to be careful. Do not think that this just goes away, because any fraction in which the numerator is equal to the denominator, the result is 1. So this would be the final answer, negative 5x squared plus 7x minus 1. Now, an alternative way to do this problem would be to factor the numerator. If you look at the numerator here, you see that 5x is the GCF, the greatest common factor. So if we factor it out, you get 5x, and then we need to see what do we have to place in the parentheses here so that the result gives us our numerator. Well, we see here we need 5x squared. Here we have 7x. And here we'll have 1. And if you distribute the 5x over each term I've placed inside the parentheses, you'll see the result is our numerator. And our denominator is negative 5x. Now, it's a principle in mathematics, or property in math, that when you have a fraction, the negative can be on the top, the bottom, or the outside. So if I replace the negative that's in the denominator to the outside and rewrite what I have, we have two factors in the numerator. One of them is 5x, the other is 5x squared minus 7x plus 1. And our denominator has 5x. So what we can do now is cross out. We can cross out the 5x in the top, the 5x in the bottom. You're allowed to cross out factors. In fact, you're only allowed to cross out factors. You're never permitted to cross out terms. Factors are things being multiplied. The 5x is multiplying the polynomial right after it. So after crossing out, we're going to be left with this negative and the polynomial that follows. And as we saw before in these sample questions, when you have a negative by itself on the outside of a polynomial, it's really a negative 1. So if we distribute the negative 1, we'll get our final answer of negative 5x squared plus 7x minus 1. This is, of course, the same answer we got before. Now, problem 8 asks you to factor completely. What that means is finding the greatest common factor and looking to factor in one additional way, either by finding the difference of two perfect squares or a quadratic trinomial. Now, to find the greatest common factor, you look at the two coefficients, the 36 and the 100, and you ask what's the largest number that divides evenly into both of them. The answer is 4. Now you look at variable names that's common to both terms. Now the x is not common, the y is common, and you take the lowest exponent. We have y to the first power in the first term, and we have y to the third power in the second term, so the lowest exponent is 1. And now we find out what we need to place inside a set of parentheses. So 4y times y gives me 36x squared y. Well, we need a 9 to get to 36. We already have the y we need, so we add an x squared. So if we multiply 4y times 9x squared, now you see we get 36x squared y minus. Now what do we need to multiply 4y by to get 100y to the third power? Well, we need 25 to get to 100. 25 times 4 is 100. We have y, we need y to the third, so we'll multiply by y squared. And now if you distribute the 4y times each term, you see you get what we started with. And if we look at what we came up with, it's actually one of the choices, choice B. But the question is this the correct answer? And the answer is no. And the reason is because we have not factored completely. If we look at the second factor here, 9x squared minus 25y squared, this is the difference of two perfect squares. And the reason is because if you look at the 9, that's a square. That comes from 3 times 3. And if you look at x squared, clearly that's a square. 25 is a square, comes from 5 squared and y squared is also obviously a square. So this can be factored. Now if you remember, the difference of two perfect squares can be factored as x plus y times x minus y. So that's the general form. So what we need to do is factor what we have. So the 4y will just be copied again. And now we see the form is going to be something plus something, something minus something. And you see the first term of each factor right over here, they're going to be the same. And the second term as well in each factor is going to be the same. So we need to ask the question, what times what gives me 9x squared? Answer, 3x. So that will go in the first slot here and the first slot here. Now we ask, what times itself gives you 25y squared? And that's 5y. So we put a 5y here, you put a 5y here, and now we have factored completely. So the answer is 4y times 3x plus 5y times 3x minus 5y. And so the correct answer is choice C. Notice that choice C says 3x has 3x minus 5y preceding 3x plus 5y. And the answer we came up with was 3x plus 5y preceding 3x minus 5y. Now, we are correct, but the form that the test uses for the correct answer has swapped 3x plus 5y and 3x minus 5y. But that's fine, because as we know, the order in which we multiply does not matter. In question number 9, you're asked to factor a quadratic trinomial. Now, 2x squared minus x minus 55 is considered to be a quadratic because of the exponent being 2. It's considered to be a quadratic trinomial because we have 3 terms. So the combination gives us a quadratic trinomial. Now a quadratic trinomial has the form ax squared plus bx plus c. X is of course the variable, and a, b, and c are all non-zero, and they're all constants. Constants being just regular numbers. See, a cannot be 0 because if a is 0, then the x squared term would drop out. And if any of these a or b or c are 0, then we would not have a trinomial. Now there are two basic ways to factor a quadratic trinomial. The first is the simple case when a is equal to 1. Now in our case, if you recall, we had 2x squared minus x minus 55. So our a here is 2. So we will not be dealing with the simple case. So we'll step down here to the trial and error case. Now in the trial and error case, you need to find factors of c. Now the c is the negative 55. And then you need to try each pair of factors until you find the correct one. Now before we begin factoring, keep in mind when it says minus x, it really means minus 1x. So the b, or the coefficient of the x here, is 1. Okay, so if you remember from the simple case, we will have two sets of parentheses. We'll have two factors that are multiplying each other. Now the simple case, since we just want 1x squared or x squared, we multiply x times x to get that x squared. Here we need 2x squared, so we'll just put a 2 here. And now you see when you do your distributing, you'll get 2x times x, which will give us the 2x squared we need. Now, in the trial and error method, we need to find factors of the c, so we're going to have to find factors of negative 55. Now we know that 55 times 1 equals 55, and we know that 11 times 5 equals 55. Generally speaking, they do not choose the correct pair to be the number itself times 1, the 55 times 1. It could be, but as a starting point, let's start with other pairs. And in this case, we see the only other pair we have involves 5 and 11. Okay, so the possibilities will be 5 times negative 11. Remember, we need a negative 55. Or negative 11 times 5, because the order matters. Or we could put the negative onto the 5 instead of negative 11. So we have negative 5 times 11. Or 11 times negative 5. Okay, so let's try 5 times negative 11 and see whether that pair works. Okay, so I will place a 5, a 5, that's a positive 5 here, and the negative 11 here. So we see we get 2x times x to give us the 2x squared, and positive 5 times negative 11 they give us the negative 55 when we're distributing. So what you'll have to check is to see whether you get the right amount of x's. We want negative 1x. So when we do this distributing, when we distribute the 5 over the x, we're going to get positive 5x. And when we distribute the 2x with the negative 11, we're going to get negative 22x. Now negative 22x, let's just correct that. So we'll get negative 22x minus 5x, and that equals negative 17x, which is not what we want. So this pair is not correct. So let's try the next possibility. Is negative 11 times positive 5 going to be the correct pair? Well, let's begin again. 2x. Now, this time we're going to try negative 11. Times x, and we want positive 5. Let's see whether this gives us the correct answer. Well, when we distribute, we know we get 2x squared and we get the negative 55, and we have to check the x's. So let's try that. Multiplying the negative 11 times the x gives us negative 11x. And multiplying the 2x times the 5 gives us plus 10x. So what we have here is positive 10x minus 11x. Now that equals negative 1x. So this is the answer. 2x minus 11 times x plus 5. Since the problem asks for a factor and not both factors, looking at our factors, we see that the factor 2x minus 11 is one of the choices. So the correct answer is D, 2x minus 11. I want to mention one last thing before moving on to the next problem. When we were considering factors of negative 55, I said that not only do we need to consider 5 times negative 11, but we need to reverse the factors and consider negative 11 times 5. Now normally we don't care in what order factors are multiplied, but here I said we do care. Let's see why. You can see that when the 5 and the negative 11 are reversed, I no longer have the same factors. Here I had 2x plus 5. Here I have 2x minus 11. Similarly, here I have x minus 11, and here I have x plus 5. And from before, we see that the first set of factors gives us 2x squared minus 17x minus 55, whereas the second set of factors gives us 2x squared minus x minus 55.